In this video, we're continuing the iteration and we're going to look at post-condition loops. So again, a little proviso that I've had for every video. If you are with a different exam board or doing a different syllabus to IGCSE, some of the syntax may be slightly different and you need to check your specification for that, but the theory behind it is still the same. Now we've already covered count controlled loops, which is your for loop, and we've looked at pre-condition loops, which is your while loop. We're now going to look at post-condition loops, which is called the repeat until. So a repeat until loop repeats a section of code until a control condition becomes true. When the condition evaluates a true, the loop is exited. So we do something, we check if the condition's met. If it has been met, we continue with the program. Otherwise, we'll go back to the start and check again. Now, as I've said, the repeat until is known as a post-condition loop. Now this is because the exit condition is checked after the statements within the loop have been executed. And this is even true if it's the first time the loop's been executed. So this means that the statements within the loop will always be executed at least once, whereas with the while loop, you may never actually execute any of those statements. So the exit condition is the same as a while loop, where it can be pretty much anything. So it doesn't have to be numerical, it can be any logical condition. So it could be numerical, but it could be input equals Bob, X is true, X is greater than 100, anything you want that you can put in an if statement will work for your repeat until. So the pseudocode, you type repeat, and you put all of your statements, and then you write until, then your condition. So it could be repeat counter equals counter plus 1 until counter equals 10 would work absolutely fine. Now here's an example of validating an entry, so ensuring that we type in currency. So we've got a variable called valid entry, which we set to false. We then repeat, we set entry to the input of the user, and if entry is not a currency, then we output bad entry. Otherwise, we'll set valid entry to true, and then we'll keep looping until valid entry is true. So if I keep typing in words or numbers that aren't currency, it will keep looping all this until eventually it will come out. It may never come out, it may be stuck in an infinite loop if that person can't type a currency at all. Now in flowchart form, here's an example. So we've got my variable again, valid entry, we've got entry as an input, then we've got our if statement checking if it's a currency. So if it is, we set valid entry to true. If it's no, we put bad entry, and then we check at the end, is valid entry true? If it's not, we go back to the start. Now the only difference flowchart wise this is to a while loop is that you can see here where normally we'd have the check and then we'd go to a separate section of code. In this one, we're still sort of maintaining ourselves in this loop and then we go back to the start. But flowchart wise, it's very similar. And in a lot of cases, you can use a while or a repeat until sort of interchangeably. Usually though, we use the repeat until when we want to run at least once. So what I'd like to do is, after I've read the description of this task, I'd like you to pause the video and see if you can come up with the algorithm. Now there's not a one size fits all for the answer, but it should be very similar to mine, I would presume. So design a flowchart pseudocode for a guessing game where the user has to guess a secret number. After every guess, the program tells the user whether their number was too large or too small. At the end, the number of tries needed should be printed out, and it counts only as one try if they input the same number multiple times consecutively. And the program must use a repeat until. So this program could use a while, but for the sake of learning, I would like us to do the repeat until structure. So as you can see, my answer is coming up on the screen now. So I've got declare a random number as an integer. I've got user guessed, last guess, number of guesses. So I set guess to false and number of guesses to 0. I then generate a random number between 1 and 100, and then I start my loop. So straight away I'm incrementing number of guesses by 1, so it's the first go. We're then going to ask for an input, and then I've got an if statement that checks if it was equal to their last guess. Now the first iteration, they won't have a last guess, so it should probably just skip over this part. Now if the user guess is less than the random number, it outputs higher. If it's greater than the random number, it outputs lower. Otherwise, you've guessed it and it sets the boolean to true. Then the very last bit of code after my if statement, I've got last guess equals user guess, and that's just so I can record whatever they typed in last. So say if I typed in the same number again, when we get back to this section, it'd say that they're both the same, it'd say you've guessed that already, and knock one of the guesses off so I'm not losing out on points. Then it's going to keep repeating until I guess it correctly, and then it'll bomb out and continue with the rest of the program. Now, you don't have to use a boolean like that. What you could actually have done is done something like until input equals random number or something like that, and you could have taken out this part really. So you could just have an if to do the higher or lower and the last guess stuff. Either way works. It's probably, you could argue it's more efficient because you're not using one variable there. I'm not using guessed, and I could just take out user guess and just have input. That would work as well. But for me, this is how I'd like to do it. But if you're doing it that way, that's absolutely fine. And hopefully that helped. You understand post-conditional loops, you understand the repeat until, and give it a like, subscribe, and I'll see you in the next video.